Now we are going to see about community detection in e-commerce recommendation system. First of all, what is e-commerce? E-commerce refers to the process of buying, selling, transferring or exchanging products, services or informations via electronic networks, mainly the internet. It uses websites, mobile apps and digital platforms to support commercial activities without the need for physical interaction. What are the platforms? Platforms like Amazon, Flipkart, Myntra, Zomato, etc. recommended products to the users based on similar interests, purchase history, and behavior patterns. A powerful approach is to represent users and product as a graph and apply community detection algorithm to the group with similar users or similar products.
Now we are going to see about the graph model. There are two types of graph model: user graph, user product bipartite graph. First, user graph. Here, nodes represent the users. Edges represent the connection between the user who shows similar behavior. For example, they bought similar product, gave similar ratings, or viewed similar items. Next, user product bipartite graph. First, what is bipartite graph? A bipartite graph is a special type of graph where nodes can be divided into separate groups and edges only connect nodes from different groups, never within the same group. Here, two sets of nodes. One is users and another one is products. Edges link a user to a product they bought, viewed or liked.
Now we are discuss about why community detection. Community detection is a visual process in network analysis because it helps uncover the underlying structure of complex graphs. Next, community detection helps in finding groups of users with similar tastes, finding groups of products bought together, improving recommendation accuracy, then reducing search spaces for algorithm. Then a community is a cluster of nodes that are more connected internally than to external nodes. How it relates to graph structures. Community detection is applied to different graph types such as those used in recommendation system, user graph and user product bipartite graph. User graph, nodes are users and the edges represent similarity. Then user product bipartite graph, nodes are split into two sets, user and product. Edges indicates user action.
Algorithm used in e-commerce. It contains various methods. First method is Lowian method. Group nodes by maximizing modularity. How dense the community is internally. Works in two steps repeatedly. How moves the neighboring communities if modularity increases. Collapses community into a single node and repeat. Best for large e-commerce graphs. Millions of products. Fast and scalable. Another method is Griffon-Newman algorithm. Find communities by removing edges with the highest betweenness. Edges acting like bridges. As bridges are removed, the graphs are split into clusters. Create a hierarchical structure. Slopes suitable only for small graphs. Another method is spectral clustering. Uses eigenvalues, eigenvectors of the graph, Laplacian to embedded nodes in low dimension spaces. Then applies k-means to form communities. Captures global structure web. Computationally expensive or very large graphs. Another method is label propagation. Each node repeatedly takes the most common label among his neighbor. Label spreads until they stabilizes. Very fast and scales to huge graphs. Good for dynamic and frequently changing graphs.
Let us discuss about the step-by-step working process. A graph-based recommendation system is a method used by shopping websites to suggest product to users. In this system, users and products are treated as nodes and the connection between them are treated as edges. By studying how users interact with products, the system can find similar users, similar products and groups of users with similar interests. Using this information, it can recommend the most suitable product to each other. Let us see the step-by-step process. Step 1. Build the interaction graph. Create a graph where users are linked to products they buy. If a user buys more products, more links are created. We can add weights such as a frequency of purchase or rating. If a person buys the mobile 3 times, then connection weight equal to 3. Step 2. Convert to similarity graph. From the interaction graph, calculate similarity. There are two types of similarity: user similarity and product similarity. First, user similarity. Users who buy similar items have a strong connection. Next, product similarity. Product often brought together also form strong links. Example, if many users buy mobile phone plus charger together, strong similarity between these products. Step 3. Apply community detection. Group similar users and similar products into communities. User communities, mobile buyers, fashion buyers, home appliance buyers, product communities, electronics, books, furniture buyers. These groups help understand user interest. Step 3. Generate recommendations. Based on the community a user belongs to, suggest useful items. Example, if a user is in a mobile buyers community, recommend popular mobiles in that group. Accessories like cases, chargers, earphones brought by others.
By seeing this diagram, we can understand the user product graph. Now we are going to see about application in real e-commerce system. First one is Amazon. This is a purchase pattern community style. Amazon groups users who show similar buying patterns. All users who buy related items are placed in the same community. Example, mobile phone, charger, earphone, etc. Flipkart or Myntra. This is a fashion trend community style. Flipkart and Myntra focus on fashion communities. They create groups of users who purchase similar clothes styles, jeans, shoes, t-shirts, etc. Next one is Netflix. Netflix also uses community detections for movies and shows. They do group users who watch similar genres, recommend movies watched by people in the same group. Advantages of community detection in e-commerce: it gives more accurate recommendations, which means users with a similar interest are grouped together. The system can recommend products that matches the user real preference. It also finds hidden behavior patterns. If a person buy mobile phone means he also tend to buy phone case. It reduces computations. Instead of comparing every users with all other users, the system only works within small clusters. It reduces time and improves performance. Works even when user data is very small. New users or rarely activate users can still get recommendations because they can be placed in a suitable community based on minimal informations. Conclusions: e-community detection using graph structures helps e-commerce platform also. It understands user behavior. By analyzing communities, business learn what type of users like. It also groups similar users and products. Users with a similar taste are grouped together, and products often bought together also forms groups. It provides personalized recommendations. Better clustering leads to more relevant and customized product suggestion. It also increases user engagement and sales. When recommendations are accurate, users spend more time on the platform and buy more products.